Hello, I am here at a pond near my house to collect some water for HPL discovery. There is the pond water. Do you think it's safe to drink this water? It's got so many impurities. Now that I'm home, I can just turn on my faucet and get clean drinking water. So how did this kind of water that I got from our little pond become this? The source for this water is also rivers and reservoirs, which are slightly bigger than our little pond, but still collect all the impurities that our little pond collected. To learn more about this, I reached out to the Hillsborough Water Department. Due to COVID restrictions, I was not able to go to the water treatment plant, but I got some video footage of Chris Wilson, one of the managers at the water treatment plant in Hillsborough, telling us how and where our tap water comes from. This video was originally made for adults, but I have taken excerpts of the video to give you an idea of what happens in a water treatment plant. Let's take a look at this short excerpt.
We do run 24/7, 365, where someone's here all the time, day and night. Well, there you can actually see the kind of the area that we're supplying. Currently, we are the largest conventional water treatment plant in the state of Oregon. We get water here from the Tualatin River is our primary source. During the summer, when our demands are high, the Tualatin River cannot keep up with our demands, so we release water from Barney Reservoir and Hag Lake. Yeah, can pump up about, I think our goal was 88 to 90 million gallons a day, because we will lose some of that water within the process as it goes through the treatment process. This is our flash mix, where we add alum, we add chlorine, and we have the ability to add powder activated carbon for taste and odors or cyanotoxins. And we add, I'm missing something there, caustic. We have the ability to add sodium hydroxide to help bring up the pH. For times during winter storms when there's a lot of rain, it'll tend to drive the pH down. Our alum doesn't work quite as well during those times, so we add caustic to add alkalinity. From the rapid mix, we have 7 sedimentation basins. The coagulation, we have big paddle mixers that are going to mix, create the flock. The flock moves into the settling part of it, where it's heavy enough to settle out onto the floor of the basins. The clean water comes out the end of the basins and moves over to the filters. We now have 16 filters, dual media. We have anthracite and sand. From the filters, the water enters what we call the clear well. The clear well is where we get our contact time, disinfection. About 1 million gallons, I think it's 1.2 million gallons of the clear well, where it then goes into pumps. We have 2 different pump stations. Pump station 1, again, the older facility. Pump station 2 is added in the 90s. So they both pull from this clear well and pump out into the distribution system.
If you did not follow everything that was said in that excerpt, it's okay. In your discovery kit, you have materials to examine 2 of those processes in detail. Let's first look at coagulation and sedimentation. Oops! Look at what a mess I've made. To clean this up, 1 sesame seed at a time is going to take forever and I still won't be able to do everything, pick up everything. So what do you think is the best way to clean this up? Aha, if you are thinking, come on, Miss Deepa, make little piles of the seeds and then it's going to be so much more easier to clean. Then you are talking about coagulation. Coagulation is the process where smaller particles are brought together to form bigger clumps. And this coagulation is done in the water purification process by adding the chemical alum or aluminum sulfate, which is included in your kit. So when the particles all get together and form a clump, they become heavier than the water, and the clumps sink down into the water. And this is known as the process of sedimentation, or settling down. So coagulation and sedimentation go together as one process to clean some particles from the water. Here's how you can start the coagulation process. Take a transparent container, any container that is transparent. Here's my pond water. I'm going to just shake it up a little. And then pour it into the container. And there's my dirty pond water. You can make any dirty water by just adding impurities to it. But this is my pond water. And then, as you can see, there's a lot of little impurities in there. Now, here's alum. I'm going to add a couple of spoons of alum to this pond water. And stir it slowly for about 5 minutes. Once that's done, just set it aside for it to coagulate and form a sediment. Let's look at the next process that we are going to examine while our pond water is getting coagulated and sedimentation is happening. We have to leave it for that. So now the next process is filtration. So what does filtration do? Filtration has a medium through which the liquid is passed through. So in your kit, you have 3 different mediums: gravel, coarse sand, and fine sand. Why all of this? What do they do? Let's examine gravel. So let's just look at gravel particles. They are larger particles and each one is of a different shape. Look at that one and that one. And even though they are larger particles, they're all of different sizes and different shapes. So when you put all of the particles in a layer for the filter, then no matter how close you pack it, it still leaves holes. See that? Because of the irregular shape and size of the gravel. So since the gravel particles are larger, the holes that it leaves are larger too. So what happens when you put water on this layer? Right, the bigger particles of dirt and dust get filtered out, or the water just goes through with the smaller particles, and the bigger particles stay on top of this filter layer. Here are the 3 mediums for filtration that you will get in your kit. Gravel, coarse sand. Do you see the size of the particles and the gaps that it might have? And fine sand. So make your filtration setup. Instructions are included in your kit. Can you guess what kind of impurities each of these mediums would filter out? Here is the filtration setup that I have. I have closed the mouth of the cut bottle with the filter paper and rubber band. And there is the fine sand, the coarse sand, and the gravel. I'm going to pour in my dirty water into this filtration setup. And see what happens. There's the water filtering out. Here is the filtered water, and there's the dirty water. Okay, here's a question, because science is all about asking a question and trying to answer that question. If you look at the fine grain of sand, what kind of impurities do you think this will be able to stop? Will it be able to stop the bigger impurities? Will it be able to stop the tinier impurities? Depending on your answer, why do you think there are 3 different grades of filter medium? Experiment by layering them in different ways. Putting the fine sand first, and then the coarse sand, and then the gravel, or interchanging these and seeing how much time it takes to filter your dirty water. And if you find the answer to why you need 3 different grades of the filter medium, write to us. We would love to hear from you and see what experiments you did, what you discovered with our HPL to go discovery kit. Remember, your filtered water is still not ready for drinking because we have not disinfected it. Have fun, experiment, ask questions. Until the next discovery kit. Ciao.